Ares 1X did have a very good master schedule that linked all the IPTs together. This was a very positive as well as a communication tool. It acted to keep the different IPTs in sync for their deliverables to each other as well as to the mission, because the total outcome is the mission. So that's really what the schedule was held at. It was held at the mission level, and the deliverables going forward were used as milestones, and that's actually what we reported upward. And these milestones were held at the level 2 level, and when also we had level 1 milestones that were held.
Using the excuse, if you will, of requirements not being ready up front was not going to work well with Ares 1X because of the fact that we recognized that they were going to evolve and change over the course of the 3.5 years that we were a project team, and that this was a compressed schedule. So we had to build a mindset early on within the project team to accept that, and from a lessons learned standpoint, if you are going to have a schedule that is compressed like we had, you accept that up front and establish the mindset that you are going to have to do concurrent requirements development, concurrent design, concurrent fabrication perhaps, with the knowledge that you may be at risk in some areas where you may have to go back on the design, you may have to pull hardware out of fabrication and scrap it and start over again, but you're hedging your bets that, hey, you may be guessing right against how the requirements will actually end up.
For Ares 1X, we did, it was a very aggressive 3-year schedule. And there were times when we were in the design phase, the manufacturing phase, and the operations phase simultaneously. And obviously nobody would put that together up front as the best way to go do a project. Classically, you do your design phase and you have a review, and you go into manufacturing and you have a review, and you go into operations phase, and it looks pretty on paper. But when you have a due date, and schedule is important, sometimes you tweak a little bit. And so what we did is we identified high-risk areas, and high risk for manufacturing and later high risk for operations. But the design to manufacturing interface or milestone trade-off is probably a good one to explore. So we were in our design phase for a while. We provided very big, very high level of environments to the IPTs to say we probably won't see anything that exceeds these values, so go design to these. And over the course of the next couple of years, we'll try and refine what these values are for loads or for thermal or aero, whatever you want to use. But try and design this very big number over here, and you'll always be okay. We'll never exceed that. And that was our approach. To start up something high, to design it really high factors of safety, and then we'll be okay as we mature our loads. And in most cases, that came out to be true for us. And as we were going through our development, and we still kept our launch date where it was, there was that point in time where the schedule said, you got to start manufacturing. And so we were starting to get a little concerned when we were still in the design phase, and that manufacturing point was coming up. So the IPTs were coming to us and say, hey, in order for me to meet my schedule, I got to start making this thing next month. But you're still working on the external loads to the vehicle, and so I'm at risk. I mean, it's uncertain that I can start building this piece, and then a month from now or 4 months from now, you can come back and say, oh, by the way, the loads are higher and this needs to be thicker. And so what we did is we bubbled all of those manufacturing decisions up to our highest control board level. And so before you go and design and start manufacturing something prior to the CDR milestone, and classically you wait till after CDR to go build something, we started way before our system CDR to building components. We said, before you go do that, you come over there and we'll talk about it. And we'll see whether it's a little gusset plate that costs us almost nothing to redo, or it's a big piece of structure that once you start, milling this out, if we're wrong big. Like we're off by another year or two to get some replacement parts. So we had discussions of all the critical areas that had big consequences if we were, quote, wrong in our initial environments. And by doing that, it was really a form of risk mitigation. Understand what we're about to go do, what are the consequences, if our loads go up, how would it affect this component? And in almost all cases, we gave the go-ahead for those IPTs to start manufacturing their hardware after their CDR, but before the system CDR, and keep us going. By doing that approach, helped us compress the schedules, kind of put the manufacturing and the design phase in parallel with each other for a while. And then once we got to the system CDR, we were pretty much done with the design phase, and we were into the manufacturing phase. But the same thing happened. Now we were pretty much at the operations point where it should be starting.
We're about ready to bring the hardware to KSC, and yet it's not all built yet. And we have to write procedures, we have to understand test and verification that we're going to do while the hardware is here. Well, the guys are still building it. They're busy doing that, and they don't have time to write the procedures and do the test requirements and all those sorts of things. So we took it upon ourselves, particularly here at KSC, as KSC, as the ground ops people, as well as representing some of the SE&I function, we would go out to the places where they were building the hardware. And those engineers who were going to write the procedures and lock in the requirements and the way we were going to do tests, they would go talk to those folks. And so concurrent with building and manufacturing, we were talking about writing procedures. We were writing procedures. We were filling out those test documents, those sorts of things. And if we had not done that, once again, we'd be sitting here 6 months from the day we actually launched talking about it's still going to launch sometime in the future. So concurrent engineering for Ares 1X was a tremendous success. And if you're ever going to do a fast, lean project, you're going to need it. So that's just a huge one for everybody.
The key for us for 1X was that we made decisions when the schedule said we had to make decisions. And we say next week we have to decide on the following thing because it affects operations or it affects the manufacturers of a piece. But wait a minute, we're not ready. We haven't finished all the analyses and all the tests to make that decision. So the classic way would be to put off a decision X amount of weeks until you're finished. You have all the information ready for you to make that decision, and then everything else waterfalls obviously to the right in your latent schedule. We didn't want to do that. We want to say, okay, we're going to make this decision the best we possibly can at this point in time with all the information that we have available to us. And we'd go through, here's what we have. We have this over here. And the next week or next month, we'll have the following things. And we'd talk about, well, what's the chances of it changing significantly? What other things can we do to give us insight as to where it's trending? And what are the consequences if we're wrong and we get a big surprise a month from now? And say in many, many cases, we made the decision with, a much smaller amount of the information than people classically would expect. And we had to for our schedule. We took the risk that we could be wrong and the risk that we could find. But mostly, to me, it was, as a manager, more confidence in our team that we would find a solution. I relied heavily on the talent of our team that we would fix or find, a solution to almost any problem that we would have. And by doing that, we made decisions when the schedule said we had to make decisions. We kept people moving. We kept finding, new opportunities to make decisions, and the whole team just kept moving forward and moving forward and moving forward. And after a while, that's infectious. When people realize that we're doing this, it's not when we get around to it or when the analysis is done. It's like, no, we're doing this piece. We're going to stack here. We're going to stack here. When people realized that there was no kidding, we're going to stack on these dates, it was miraculous how much stuff got done to support that.
As far as decision making on Ares 1X, it was the toughest thing I've ever had to do because we were moving so quickly, and we made very conscious decisions. Now, this is one thing that our mission manager did better than anybody I've ever seen, which is to say, okay, we are, by the classic design model, we are not ready to proceed to the next step along this timeline. But we're going to bring everybody in. We're going to talk about what we're missing, why we're quote-unquote not ready to go. We'll talk about those things that are not ready. And if it's okay, if we can get comfortable that we're taking a fairly low risk, then we're going to press on. And we did this time after time. Very often the hardware was not quite finished or the design wasn't quite finished, and we were going to proceed on the next step, which would be to build or go start stacking. And when you have these big meetings and you talk about very openly, again, communicate, and you talk about these things very openly, you can find out what the real problems are, and then the project manager, or in our case the mission manager, he can make a very informed decision about what risk he is accepting and what steps he could possibly do still to mitigate it and yet still make the schedule. Because one of our driving factors was find out as early as you can what your problems are going to be.
And if you have a series of tasks in your schedule, and you have to do A, then you do B, then you do C, and A is taking longer than you think, B will start later, and C will start later. Or you're going to have problems in B and C. And the longer you wait to finish A, the longer till you find those problems in B. That means the less time you have to fix those problems and react to those problems if you keep your launch date the same or close to the same. So that's a challenge. And so my suggestion is don't do that. Start B when B's got to start, even though it may be earlier than you think relative to task A. But get those problems found early, then you have more time to solve them. So when we were putting our vehicle together, we pushed as hard as we could to assemble our vehicle and working multiple shifts, just working people hard to get those together. And because we wanted to get to the next level of problems, which was running cables and running harnesses and getting electronics. And we pushed to get those done because we wanted to get to the next phase, which was doing the integrated testing. That was the one where we power on and see if the vehicle works from an electronics point of view, was our highest risk area from putting the vehicle together. So every movement up front, every 1 or day 2 slip over here, gave me, in my mind, 1 or 2 days less to troubleshoot those really hard problems that are coming up. So we want to move all the problems to the left. Find your problems early. Just even though you don't think you're ready to start phase B, start it anyways. And if you have to stop because a piece of hardware isn't ready or you're waiting for some software, okay, then stop and wait till you get that piece of hardware. But in the meantime, get as much as you can done now to find those problems you're going to find. So when we did our testing of our DFI, we had over 700 sensors. It was a very unwieldy set of sensors and harnesses and test setup and checkout to go do all this. It was very, 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 very difficult, a lot of work. And we wanted to wait till we got a full configuration and test them all, and which sounds good. And then it was going to take 2 days or 3 days and 4 days and a week. The time period to go do that testing kept getting bigger and bigger and bigger. So what we had to do is say, no, you're done by Friday. And they said, well, no, but we got this to do and this to do. It says, no, you're done by Friday. And with Friday, if you don't test them, then we'll either pull those sensors out or we'll fly them untested. And because we need to get into the next phase of testing, we need to start, which needs to start the following week. And after going through that shock from the tester is that we have 3 days now, not until we finish our matrix. A couple things happened. One, we finished by Friday because people realized that they got to find a way to do it more efficiently. So it really drove the thought process of how to be efficient. 2, we found problems, and we found problems in phase B once we started it. But we were able to solve them and still keep on track because we found them earlier. Had we waited another week, that would have been a week later. We probably would have canceled the testing for phase C because we spent all of our time troubleshooting phase A and phase B. So strong belief, find your problems early, start when you got to start, even if it's not perfect. Don't worry about it. The 80% solution is good enough because the other 20% is going to change anyways, so don't worry about that last 20%. So just concentrate on what you can do up front. And you'll be amazed by finding problems early how you really stay on track for your schedule.